Okay, it seems to be working. Okay, let's start. Okay, so hello everybody. This is Luboš Pirkl from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a CFD simulation workflow for all standard rotating machinery. The test case for today will be a Kaplan turbine. Just in case of any technical problems, feel free to contact us in the future and we will gladly answer all your questions or reminders. The webinar is going to take up to 1 hour. In the first part, I will show you how to simulate a Kaplan turbine. In the second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions to the comments, to the chat window, or send me an email to lubos.pirkl@cfdsupport.com. I will answer your questions or reminders later in this webinar. So do not hesitate to put your questions. It's your time, and I'm here for you. And it's a great occasion to show you and to have a nice discussion here today. So, okay. So in the beginning of today's webinar, I'm gonna be quite general, and well, so feel free to put your questions, and then I can go to the details and really answer everything. I'm here for you. So, okay, so let's go for it. I guess I start. So I share you my screen now. So I'm sharing you my screen, and now I believe you can see what I can see, which is a web browser. Okay, so yeah. So let me start with a brief description of what is Turbomachinery CFD. So Turbomachinery CFD is a unique software based on OpenFOAM. It was designed especially for rotating machines, but it can be used for any CFD simulations, but originally it was designed for rotating machinery, such as pumps, fans, turbines, water turbines, both radial and axial machines, yeah, both compressible and incompressible fluid flows. Turbomachinery CFD is a complete CFD workflow that covers complete set of steps from the pre-processing of the simulation to the result. So Turbomachinery CFD has its graphical interface, and 100% of workflow is served from graphical interface. Now you can see this is the graphical interface, and you can do everything from here. But before we come here, maybe let me put just a quick review of Turbomachinery CFD's unique value proposal. So I'll go to my browser, and I'll go to the products section in our website, and I will click to Turbomachinery CFD, and yeah, I will just briefly describe the value proposal. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores. And obviously that gives their investment into Turbomachinery CFD a permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the start to the final results report can be run by a single command or by a single click, and all the process is being done automatically. Number three is Turbomachinery CFD is open source, and that makes it easily customizable, and it's easy to modify it to your own purposes, to modify it to your workflow, to your needs, to your habits, to what you like. Number four is the real tutorials are included. so the user has no doubts about the best practice settings. So there are real machines that are already preset, and you can take them one by one, or you can take any of them and replace a geometry and modify the settings and run it. So the best practice settings is included, and some real machines are included. So it's pretty comprehensive. Okay. There are many other benefits of using Turbomachinery CFD. Of course, I'm not going to go for all of them. The most important thing of today's webinar is all the information is available online on our website. So if you would or should remember just one thing from this webinar, it's this: all the information is available online. So visit our website and you can get all the information pretty easily. Okay. Turbomachinery CFD is available both for Windows and for Linux operation systems. And that's important. Turbomachinery CFD is transparent. So there is a trial version available for free for 1 month of period of time. So anybody can try Turbomachinery CFD, and afterwards he or she can decide to buy or not. So any decision can be taken after you can try it, you can test, you can do your simulations. So full version is available for 1 month. So you know very well what you buy if you decide to buy. Okay. You can like, maybe what's important, you can click on our website, you can click the download, and in section download software you can download for example a version for Windows, and you can follow step-by-step PDF. So there's PDF which is called Start Turbomachinery CFD Step by Step, and there are all instructions you need to do to make your first simulation. So yeah, so there's the demo version available. That's important. And also there are test cases, the tutorials available. Currently we have 1, 2, 3, 4, 5, 6, 7 tutorials available. There's axial fan, there is a pump tutorial, the radial fan tutorial, Francis turbine tutorial, radial turbine tutorial, radial compressor tutorial, and finally the Kaplan turbine tutorial, which will be a case we will speak about today. So if you can just put your email and you can click download, and you can have everything, and you can do the simulations this afternoon. So it's so simple. Okay, so my last point is, yeah, all the information is available online, and if you would like to know anything, just tell us. We are pretty transparent. We like to communicate. We will describe everything to you. So really feel free to contact us, and we will answer all your questions. Okay, so this is how to get the demo, how to get the tutorial, what to do to run it. And which brings me back to the graphical interface of Turbomachinery CFD. You can run it by it's the ParaView. So all the Turbomachinery CFD is combination of ParaView and OpenFOAM. It's OpenFOAM. It's pretty yeah. Everybody knows what's OpenFOAM. It's open source, written under GPL license, so it's available to anybody. Anybody can download it, and etc. etc. So we have developed special libraries and special applications for OpenFOAM. That's on the CFD side, and on the user side there are a couple of libraries for ParaView, and altogether it creates Turbomachinery CFD. Okay. Turbomachinery CFD is fully served from graphical interface, which is this. That's the ParaView. You can also work from terminal, but most people choose to work from graphical interface. So the decision is up to you. And also you can run Turbomachinery CFD on clusters, and perhaps then you should use terminal. But anyway, the most of people work with the graphical interface, which is ParaView. The workflow is exactly the same in Linux and in Windows. So it's again, the operation system is the user's choice. Okay, so today there is a Kaplan Turbine tutorial, which anybody can download from our website, and you can load it to Turbomachinery CFD, or you can get the demo work, and so basically you can have the same what I have. Yeah, so the Kaplan Turbine. The aim of a Kaplan Turbine designer is all the time is hunting for the head, or the turbine head, the flow rate, the torque, and of course the efficiency, which is a function of these three quantities. What's also important is cavitation potential or cavitation risk. So that all these things are solved directly and automatically in Turbomachinery CFD. So okay. Each Turbomachinery CFD simulation has the same data input. So Turbomachinery CFD reads, I mean the basic line. So reads the surface geometry, which is the 3D surface model of your rotating machine. It's the Kaplan turbine for today. So it's the surface. So those are like planes in 3D, and it's the settings. So the settings is a plain text file with .tcfd extension, and it's plain text file like ASCII file, and there you can see all the settings, and of course you can read it. You can read it into the ParaView. So I can see my settings right here. So I just briefly mention there are many parameters. It's like coordinate system, axis of rotation, scaling factors, of course the physics like dynamic viscosity of fluid, reference density, reference pressure. Yeah, what's important, there are also number of points and number of speed lines. So you may compute your machine under different number of rotation speeds, and also each speed line may have any number of points, and each point has its boundary condition, of course. So for example, this turbine is being simulated with volumetric flow rate at the inlet and static pressure at the outlet. There are 3 points that will be simulated, and each point has its boundary conditions. So this Kaplan turbine has, for example, the point number 1 has 70 cubic meters per second, 80 cubic meters per second, and 90 cubic meters per second. So these 3 points will be simulated. There are some settings, of course, number of processors, some boundary, some quantity limitations, yeah, and some mesh settings, which I might speak about this later. So anyway, the input is the settings and the surface geometry. Those are the inputs. So there's the settings, and so you once you have these settings, then you need a special filter which is called TCFD manager, right? So we have included into ParaView a special filter which is called TCFD manager, and if you use it on these settings on this .tcfd file, you have a special menu where you can decide what to do with your case. So Obviously, you can write down the case, and you can, for example, create the mesh, or you can run the simulation, or you can skip between points which are about to be simulated. And what's also important, you can update your results report anytime. So what you can do also, what you can also do is you can run everything in one. So you can write down the case. It's everything is being stored on your hard drive, and all the agenda, all the meshes, everything is stored in your case on your hard drive, and you handle it through this interface, right? So okay, yeah. So you can run everything in one. Yeah. So you can go one by one, or you can run everything automatically. What's quite important, also during the simulation, anytime during any simulation, you can view the results immediately, all the time. So every simulation has its report in HTML format, so it's ready for your web browser, and you can watch everything. You can see some statistics. For example, how your flow rate is developing in the outlet and in the inlet of your machine. What are the residuals of the main quantities that are simulated? What are the mesh cells, computational time, number of processors, and there are a couple of sections in this report, right? For example, the efficiency. So you can see how the efficiency was developing in time during your simulation, or how it, and also plot how is your efficiency against the flow rate. The same with torque. The torque is evaluated, and you can see how it developed, and what was its average, and how it's plotted against the flow rate. And again, the total pressure difference, which is the head, basically the measure of head. Then you can see total pressure per interfaces. So you can see, because every component of your machine, for example, the inlet tube, the draft tube, the rotor or the impeller, or the spiral or the inlet tube, for example, all of them, they have their inlets and outlets. We call them interfaces. We merge all the model in via these interfaces, and each interface has evaluated its total pressure. So basically, you can watch here. You can watch how your energy, your total pressure, is being spent over when flowing through your machine. So total pressure per interfaces, quite important value, and also flow rates per interfaces. The same with velocity magnitude. You can see what's the average velocity over your machine at every interface. You can see what are your angles, the circumferential and meridional angle at every interface in your machine. You can see how they develop, and those give you the information about the flow in your machine. And finally, the cavitation risk. We have implemented a special function object that tell you all the time in which or in what volume there is the critical pressure, which tell you the information about the risk of cavitation in your machine, right? So that's the report. So it's updated anytime during the simulation. You can just click many times to the update report button, and it gives you the updated report, and then you can decide to skip to the next point or abort the simulation, do the new settings, run again, and again update the report. So it's extremely effective to doing it this way. Yeah. The next thing I wanted to tell you today is there is, of course, the extensive results, visual results possibility in this Turbomachinery CFD. So maybe I should show you the, is it okay, the full model. So this is how the model is simulated. Those are the results. So you can do the visual post-processing very much in detail. And we have implemented a couple of functions together in a special set of plugins, which is called Turbo Blade Post. So Turbo Blade Post is it's included in Turbomachinery CFD, and one of its very important functions is called meridional average. So you can see you can do average any quantity in a meridian of your rotor. So you can see how, for example, your pressure or total pressure or any quantity is being spent when flowing through your machine. And especially for machine designers, it's important to see how is the average in the meridional plane, because usually these machines are being designed in meridian. So average in the meridional plane, meridional average, and of course the blade to blade view. So you can anytime do the blade to blade transformation using turbo unwrap filter, and you can watch what's your distribution compared in any level between hub and shroud, right? So you can transform your model to the model can be transformed to the plane, and then you can decide you want to see 50% between hub and shroud, or you can decide you want to see 10% level between hub and shroud, and then you can, for example, watch the velocity vectors or speed lines, and you can watch where are for example, what's the flow behavior at the leading edge or at the trailing edge, and what are your minimum and maximum of your relative velocity, for example. Anything is possible. It's really yeah, you can see it here. Yeah, okay, I see something, but anyway, that's the post-processing. So we believe we have created great and comprehensive tool and extremely effective tool for simulating of rotating machinery. And yeah, and it is, yeah, it works this way. Yeah, so maybe it's time to I'll take a look. Okay, I will stop sharing my screen for a second, which brings me back to you. Hi, I'm still here. And what I'm gonna do now is I'll take a look if I have some question to answer. So I'm clicking to my email now, and this is okay. The other guy, yeah, not for the webinar. Okay, I have a question. Okay, right. I have a question. Okay, can Turbomachinery CFD compute periodic segment cases? From Richard. Okay, Richard, thank you for your question. Turbomachinery CFD. The answer is yes, and not directly. So let me go in detail. I will go back and share you my screen now. Yeah. So currently in this version, from in the autumn of 2016, there will be new version of Turbomachinery CFD, and there will be fully possible, absolutely 100% possible to run periodic segments. So yes, from late 2016, but currently with current version, which is 16.06, so it's the version from June 2016, you should do manually one step. You should yeah, you need to say, you need to create your case, write it down, and in your constant polymesh in the boundary, you need to say there will be a cyclic AMI in your so for example there will be periodic interface, and there you should say there will be a cyclic AMI. So manually, and then you will go back and do the run simulation. So manually, but from in like 2 months there will be brand new version. There will be possible computing periodic segments. So that's the answer. Thank you, Richard. Okay. Okay, another question. Okay, good afternoon. I would like to know what is your turbulence approach? Which which turbulence models are available, Dr. Beagle? Okay, thank you, Dr. Beagle. Yeah, thank you for your question. Yeah. Turbulence models, right? Okay, so currently by default we use the approach. Yeah, the question was what's the approach? So the approach is we use wall functions with k omega SST model by default. By default, we use k omega SST. Of course, it's OpenFOAM, so it's fully compatible with OpenFOAM. So again, you can go. Currently, it's this way. You can go to your. Let me. Of course, yeah. The constant and to turbulence properties, and in turbulence properties you can specify any other turbulence model, and of course you should bring your boundary conditions in your zero directory. But yes, it's possible to use any turbulence model and any turbulence approach. It's up to you. It's not implemented in the interface yet, but you can do it manually. So anyway, you can do write the case, do the manual stuff you need to do to change everything in your constant turbulence models, and then you run manually run calculation, and it will be your turbulence model will be used. Thank you, Dr. Beagle, for your questions. I will take a look to my inbox. I have to say I can't see any other questions for now. I'll go back to the to the webinar, and I have to say I can't see any question here. So I'll go. I have the other computer here, so I will. Give me a second. I can stop sharing my screen. Okay, I'm back here. Hi, and I will take a look to my email, to my inbox. Okay, no more questions. There are no more questions. So okay, so I guess this is it for today. Thank you very much for spending time with us. It was a pleasure, especially with Richard and with Mr. Beagle. It was a pleasure answering your questions. So thank you for them, and yeah, thank you for your time. Anyway, feel free to put your questions, send me an email to lubos.pirkel@cfdsupport.com. Feel free to put your questions anyway, or send it to info@cfdsupport.com. Put your questions, feel free, we are here for you. We believe we have created something big, something really great. The Turbomachinery CFD is extremely effective we believe it's also affordable compared to what's available in the market. We believe we have opened a special, from September 2016, we have opened a special program for universities with extremely great conditions. You can get Turbomachinery CFD to the university, the full version, the full technical support from us, and we believe it's comprehensive. We are strongly developing Turbomachinery CFD, so the new versions are coming. The very effective tool is here, and it's our job to tell people and to tell out loud it's here. So we are looking for it. It's a big challenge, so we face it. We like it. We are here for you. So thank you for your attention, and we are looking forward to collaborate with you. So thank you and bye bye, and speaking to you next time, maybe live. Okay, bye.